Hello students, this is SANTOSHSIR again from Parth Tank Mathematics Institute, Ahmedabad, and in this video I will take you through the solutions of NTA's test paper number 10, the mathematics part. Let us begin. The solution of dy by dx, let us rewrite it, dy by dx is equal to 2 cos x minus y cos x cosecant x, where at x is equal to pi by 4, y is equal to root 2. Okay, this is a very simple question. Rearrange this, bring this term here, plus y into cos x into cosecant x. Cosecant x can be written as 1 by sin x is equal to 2 cos x. Therefore, this equation is of the form dy by dx. Let us write it one more step simpler. Dy by dx plus y cot x is 2 cos x. So this is like p and this is like q. You know, right? Dy by dx plus p into y plus p of x into y plus q of x is equal. This can be solved as y into e power integral p dx is equal to integral of q e power integral p dx, where this integrating factor is this e to the power integral p dx. And especially these are very good integrating factors. Let's see how. Let us write the equation once more here. Dy by dx plus cot x into y is 2 cos x, right? Now the integrating factor e raised to integral p dx is nothing but e raised to cot x dx. Now we know that integral of cot x is log of sin x. Therefore this becomes just sin x, e to the power log. Okay. So the solution is y sin x is equal to integral of q into the integrating factor dx. Now what is this? This is nothing but 2 sin x cos x, nothing but sin 2x basically, right? So this is sin 2x dx, which can easily be integrated as cos 2x by 2 with a minus plus c. So y sin x is equal to minus cos 2x by 2 plus c is a solution, and they have given that at x is equal to pi by 4, y is root 2. Let us substitute this to solve for c. So root 2 into sin pi by 4, which is also root 2, minus cos 2 into pi by 4 is pi by 2, which is 0. So this becomes root 2 into 1 by root 2 is 0 plus c, or c is equal to 1. So y sin x is equal to 1 minus cos x cos 2x by 2. Now of course this form is not there, so we have to simplify this a little bit more. How can we do that? If we write this as y sin x is equal to 2 minus cos 2x by 2, taking 2 as the LCM, and this further as something like this. We know that 1 minus cos 2x is 2 sin squared x. So that by 2 still here, which can be separated as 1 by 2 plus sin squared x. Now take this sin x to the other side. I get 1 by 2 sin x plus sin x, right? Divide both terms by sin x. So this is nothing but half cosecant x plus sin x. So y is half cosecant x plus sin x is there. Y is half cosecant x plus sin x, option A. So very simple question. It is this linear equation of the first order. Dy by dx plus p of x into y is equal to q of x. Find the integrating factor and then you're set. Second question. The domain of the function f given by f of x is equal to 1 by square root of box x square, remember box x, the greatest integer function, minus box x minus 6 is. Now it's very simple. If you understand that anything within the square root cannot be less than 0, so this always has to be greater than 0. Or what can we say? If you factorize this, there is nothing but box x minus 3 into box x plus 2 greater than 0. Therefore, the roots of this equation, quadratic equation, are box x is equal to 3, and then there is a box x equal to minus 2, right? Now since it is a quadratic inequality and a greater than sign, we know that it has to be outside the interval, right? That is, box x should be greater than 3, box x should be greater than 3, and the same way box x should be less than minus 2, okay, because it can't even be equal to. If it is equal, then this is going to be 0 and it is going to be 1 by 0, which is infinity. So this is the condition, box x greater than 3 and box x less than minus 2. Now from where will box x be greater than 3? For any number that is starting from 4 onwards, right? Box x greater than 3 will work for any number starting from 4. So this is this. And box x less than minus 2 will start from, like, for example, minus 2.1, box is minus 3, right, which will be less than minus 2. So any number less than minus 2 is going to satisfy this, but any number greater than 3 won't satisfy this, because if you take 3.1, box of 3.1 will be equal to 3, and that would violate this condition. So here you can say any number that is less than minus 2 not included, because remember it makes it 0, is okay. So 4 to infinity, closed interval, and minus infinity to 2, which is oh my god, both the options are exactly the same. So this here this option is slightly different. This does not include minus 2, and this includes minus 2. We can't have including minus 2, it has to exclude minus 2, okay. So that is the solution for question number 2. Very simple problem indeed. Let us go to question number 3. The area of the region in square units above the x-axis bounded by the curve y is tan x. I remember how is y is tan x? Tan x at 0 is 0, it grows to 45 and then increases very rapidly and goes to infinity somewhere. Let us say at 45 degrees is this point. Let's say this pi by 4. They say the area bounded by this curve and the tangent to the curve at x is equal to pi by 4. That is, I draw a tangent to this curve at this point, x is equal to pi by 4. So let us say this is the tangent, okay. This is tangent at x is equal to pi by 4. So the area above the x-axis bounded by this curve and the tangent is this area, okay. So how much is this area is the question we are asked, okay. It's very simple. If you notice that you can find this total area under tan x and subtract this triangle formed here, okay. Now let's do step by step. What will be the total area? That is the full area. I am planning to do area, one is the area under the tan x curve, which is integral 0 to pi by 4 of tan x dx. Now this gives me a very simple log of secant x expression, 0 to pi by 4. Now secant x for pi by 4 is root 2 minus log of secant 0 is 1. So this is just log root 2. Okay, one part is done. Now the second is this area, right? Let me show you which area I am talking about. This area. This triangular area, if I subtract, I get the so what is this equation of this line? It is a tangent at point pi by 4, right? So let us find the equation of that line. What would it be? See, the equation of that line at that point would be the slope y is equal to mx plus c. So dy by dx, that is a tangent, is secant square x. And secant square x at x is equal to pi by 4 is root 2 squared, which is 2. So the slope of the line is 2 and it passes through the point. Where does it pass through? Let us say at x is equal to pi by 4, y is equal to 1. Tan pi by 4 is 1. So we need a line whose slope is 2 and passes through a point pi by 4 comma 1. This line is going to be y minus 1 is 2 times x minus pi by 4, right? So this is the line we are talking about. Let us say this is pi by 4. Now how to find this area? Now we know this height is nothing but 1 unit, right? Y, the value of y, 1 unit. Only this we need. And this is easy if you notice that this length would be the full thing pi by 4 minus its x-intercept. X-intercept is this length, right? So find the x-intercept of this line. Pi by 4 minus that would give us only this part. Let us call this A. So A is nothing but pi by 4 minus x-intercept of this line. How do we find the x-intercept? Put y is 0. So 0 minus 1 is 2 times x minus pi by 4, or pi by 4 minus 1 by 2 is x. So this is the x-intercept. So A is going to be pi by 4 minus 1 by 2, which is 1 by 2. So I know A is 1 by 2 and this height is 1. So the area of the triangle is half 1 into 1 by 2, which is 1 by 4. So the area that we need, area between tan x and tangent, is this area that we have found here, log of root 2 minus 1 by 4. This can be simplified a little bit if we consider that log root 2 is nothing but 2 power half. Bring that half in front, log 2 minus 1 by 4, and take the half common. I get log 2 minus 1 by 2. So the answer is half log 2 minus 1 by 2. Half log 2 minus 1 by 2 is option A. Very simple. Area under the tangent, y equal to tan x curve, and area under the tangent is just a triangle. So it's quite easy to find the area of the triangle, no problem at all. Okay. Now let us move on to question number 4. Two men are on the opposite sides of a tower, right? So there is a tower and there are two men on the opposite sides of the tower. Let us say one person A is here and another person B is here. They measure the angles of elevation of the top of the tower as 45 and 30. So he measures as 45 and he measures this as 30. If the height of the tower is 40 meters, then the distance between the men is very simple heights and distance problem. So let us say this distance is x and this distance is y. Now in triangle, let's say ABCD, in triangle ACD, tan 45 is going to be 40 by x. Tan 45 is 1. So x is 40. How about here? In triangle BCD, tan 30 is 40 by y. Tan 30 is 1 by root 3 is 40 by y, which implies y is 40 into root 3. So 40 into root 3, so that's 40 into root 3 plus 40 will be the answer. So it is none of these, this, because 40 root 3 is how much? 40 times 1.732. So this becomes like 8, 12 and then 69.28 meters. So the total length x plus y, let me write it here, is 40 plus 69.28, which is 109.28. Usually in these problems they let you stop with some number in terms of root 3 etc. But here they have given the explicit answer. So remember, square root of 3 is 1.732. Question number 5, using binomial coefficients. Let C1, C2, C3 be the usual binomial coefficients, where CR is NCR basically. Let S is equal to C1 plus 2C2 plus 3C3 up to NCN, then S is equal to. Now remember, all these questions are based on usually the binomial expansion of 1 plus x power n, because this is usually given as NC0 plus NC1 into x plus NC2 into x squared plus and so on up to NCN into x raised to n. Okay, it is in this, if you put x is equal to 1, you get 2 raised to n is equal to NC0 plus NC1. That is, sum of all the binomial coefficients is equal to 2 raised to n comes from this. Okay. Now on the other hand, if we need C1 plus 2 C2 and all, and if you basically here, what is C1 C2? This is called C0 because they have said NCR is CR. Okay, so C1x plus C2x squared plus and so on up to Cn x power n. Now here, if you differentiate, you will notice that you will get a 2x here in the next term, which is C3x cube. You will get a 3x squared, 4x cube and so on. Last term would be NCN, which is all this. So the clue is to differentiate both sides. Differentiate with respect to x. Okay. So this side is simple. It is n into 1 plus x power n minus 1. And on this side, C0 becomes 0. Here it becomes C1. Here it becomes 2C2x, 3C3x squared up to NCN x power n minus 1. Now you put x is equal to 1. And what do you get? N into 2 raised to n minus 1 is C1 plus 2C2 plus 3C3 up to NCN. Okay. So the answer is 2 into 2 raised to n minus 1. Very simple question. Starting from this, and you guess that you have to differentiate it. Now another equally interesting question would be the integration part, right? That is, it could be something like this. What happens? The problem is over. I am presenting to you another question. That is, we have the coefficients like this. Now if I integrate both sides, I get n plus 1 by n plus 1 is C0 x, C1x squared by 2, C2x cubed by 3, Cn x power n plus 1 by n plus 1. Now if I put x is 1, I get 2 raised to n plus 1 by n plus 1 is equal to C0 plus C1 by 2 plus C2 by 3 plus and so on up to Cn by n plus 1. This is another series. Okay. So you can, starting from here, derive all this. Now also, if they ask of you about the odd coefficients alone, even coefficients alone, see, come to this part, or let us say here, if they had asked only C1 plus 3, C3 plus 5, C5 and all, first thing is to put x is equal to 1 and you get something. Then you put x is equal to minus 1. That would change all this to negatives. All the even powers would become, all this term, fourth term will become negative. These will remain positive. Then add them both. All those are standard techniques. Okay. Let us move on to question number 6. If P is sine squared x plus cos power 4x, then basically what are the maximum and minimum values of P? Therefore, let us see. This expression can be simplified a little bit like this: cos squared x into cos squared x, right? What is the advantage? This is 1 minus sine squared x. So this becomes sine squared x plus cos squared x minus cos squared x sine squared x, right? So I get cos squared x sine squared x, or this is 1 minus cos squared x sine squared x. Let us simplify this one more. That is, if I realize that if I multiply a 4 and divide by a 4, The numerator is nothing but sine 2x the whole squared. Correct? Because you know sine 2x is nothing but 2 sine x cos x. Alright. So the function, given function is 1 minus sine squared 2x by 4. Now they are asking us the maximum and the minimum values, right? Now this is always a positive term because it's squared, and sine's maximum value is 1, minimum value is 0, sine squared basically. Okay? So when sine 2x is 0, p is equal to 1 will be the maximum value. When sine 2x is 1, p will be 1 minus 1 by 4 or 3 by 4, and this is the minimum value. So p will always be between 3 by 4 and 1. Now this is the easiest way to do this problem. P is between 3 by 4 and 1 is option A. Now you can do it another way also. You take this as the as the equation, differentiate it, put it equal to 0, find the points where it and all that. No, the first derivative should be 0, second derivative should be positive. Will give you the same answer. But with trigonometric functions, there are some other simplifications which help us to arrive at the correct answer without a lot of tedium. Question number 7. If P implies Q or R is false, then the truth values of P, Q, R are respectively. Okay, so we need a truth table, P, Q, R. Let us say this is true, 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 false, false, true, false, false. And for all these 4 cases, P can be true. And the same way I can have the same 4 cases and false for all the 4 cases. Now they are asking P implies Q or R. Now Q or R here is true, this is true, this is true, and this is false. Same way, true, 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 false. Because Q or R is false only when both are false. When either one is true, it is true. Now we have to do P implies Q or R. Now remember, this P implies Q or R is false only if the first thing is true and the second thing is false. Right? If P is true and Q is false, then it won't hold. Therefore, true and true is true. True and true is again true. True and true, still true. True and false is false. False and true is true. False and true is true. False and true is true. False and false is also true. So they've said that this is false, which comes only for one combination, and which is this. So PQR should be true, false, false. Okay. So the answer to this is option A, true, false, false. Very simple. Now 8 is a bit tricky question. A box contains tickets numbered 1 to n. Okay. There are tickets 1, 2, 3, 4, 5, 6, 7, 8 up to n. N tickets are drawn from the box with replacement. Obviously n can be less than n or greater than n, because you are replacing the tickets. You are taking a ticket, dropping it back, taking a ticket, dropping it back. So n times you are doing this. The probability that the largest number on the tickets is k is, that is, as you are taking the ticket, imagine you note down its number. Then the second trial you note down the number, third trial you note down the number, fourth, etc. up to n trials you note down the numbers. So you get some numbers here, and among all these numbers, the probability that the largest number is k. That is, from all this you should get only k as the largest number. Okay, what does it mean? That in all this at least one k should be there. How can we do that? First, let us find the number of ways in which you can have, see, because when tickets are numbered from 1 to n, if the largest is k, then 1, 2, 3 up to k are allowed. Right? So the first can have any k number of ways. Now the total number of ways of drawing this would be capital N to the power n, because you can fill this in any n number of ways, because of the replacement part. Now if the largest has to be k, only these are allowed, so you can have only k possibilities here. Same way another k possibilities here, up to k possibilities here. So if number is less than or equal to k, there are k raised to n ways to do this. Okay? But now you must not jump at the answer as k raised to n by n raised to n. That is there, and you click this, it's gone. Because remember, of these k raised to n ways, the number k itself may not occur, right? Which means, for example, take 5 tickets, and imagine I am drawing 4 tickets from this with replacement, and I say the maximum has to be the number 3. Okay, so I am taking 4 tickets. I have 1, 2, 3, 4 or 5. I am taking 4 tickets from this, but the maximum has to be 3, let us say. So which means I can take 1, 2 or 3 here. So 3 ways, 1, 2 or 3 I can take, 1, 2 or 3 here also, 1, 2 or 3 here also. But then this includes also the possibility of having 1, 1, 1, 1 or 1, 1, 2, 2 without 3. So in those cases the greatest number won't be 3. Okay, the greatest number will not be 3. So what you have to do, you have to eliminate all the possibilities in which only 1 or 2 will occur. That is, this is 3 part 4. But from this, if only 1 or 2 can occur, it can occur in 2 ways here. 2 ways. So 2 part 4 ways you can have 1 or 2 occur. So the ways in which at least there is 1, 3 is 3 part 4 minus 2 part 4. You understand this logic? The same way, here there are k minus 1 to the power n ways in which you can fill this without having a single k. Okay? That is, in the first place you put numbers from 1 to k minus 1. Second place also you put numbers from 1 to k minus 1, and so on. Up to the nth ticket also you put numbers from 1 to k minus 1. So you have to subtract this and this to get the actual number of favorable ways. So k power n minus k minus 1 power n. The whole thing divided by n power n is the answer to this problem, but that is not there anywhere. So the answer is none of these. Interesting question. Huh? Total number of ways is capital N raised to small n. If the largest number is k, there are k power n ways in which you can have numbers that are less than or equal to k. From that you have to eliminate everything that has only numbers less than k. Numbers less than k. If number is less than k, that is k minus 1 power n. Less than or equal to k, k power n. Less than k, k minus 1 power n. Now if you subtract these number of ways from here, you will have at least 1 k here. So the greatest number would be k. Okay, nice problem. Let's move on to question number 9. The coordinates of the focus of the parabola are described parametrically by x is 5t squared plus 2. So let me write it as x minus t is 5t squared and y minus 4 as 10t. Now let this be capital X and let this be capital Y. What does this mean? See, the parametric form of a parabola is x is 80 squared, y is 280. So compare these two, you get a is 5 and here I get 2a is 10, which is consistent with a is 5. Okay, so a is 5. So your parabola is, if your parabola is of this form, this is the parametric form of the parabola for 4y square is 4ax. Okay, so we are comparing it with that. So the parabola here for our case is y squared is 4ax or 20x. Okay, for such a parabola, the focus, they are asking us the focus is x comma y is a comma 0 and a is 5, so 5 comma 0. Now we know capital X is x minus 2. So this gives x is 7. Capital Y is y minus 4. So y is 4. X is 7, y is 4, option A. Very simple problem. Remember the parametric form of the parabolas and choose the appropriate parabola, right? 80 squared to 80 is for 4ax. If they had interchanged this, imagine 5t square here and 10t here, then you go for the parabola x squared is 4ay. And x would be 280, y would be 80 squared. Okay, be careful with those things. And then they write the appropriate term for the focus. And okay, question number 10. The rate of change of square root of x squared plus 16, let us call that u, with respect to x by x minus 1, let us call that v, at x is equal to 3. Basically they are asking you du by dv, the rate of change of u with respect to v. We know this is nothing but du by dx by dv by dx. How much is du by dx? Du by dx is simple. It is just 1 by 2 into square root of x squared plus 16 into 2x. Right? You differentiate this. Don't forget to differentiate this. What will be dv by dx? dv by dx is x minus 1 the whole square in the denominator. Then keep the denominator, differentiate the numerator, becomes 1, minus keep the numerator, differentiate the denominator, becomes 1 also. So this is nothing but minus 1 by x minus 1 the whole square. Okay. Now at x is equal to 3, du by dx is going to be, if I cancel out this, 3 by square root of 3 square plus 16, which you know is 9 plus 16, 25, 5 under square root. So 3 by 5. Here dv by dx is going to be minus 1 by 3 minus 1 the whole square, which is minus 1 by 4. So basically du by dv is du by dx by dv by dx. So if you divide these two, du by dv is going to be du by dx upon dv by dx. And we found those values as 3 by 5 and minus 1 by 4. So this is minus 12 by 5. So the answer is minus 12 by 5, option C. Okay, very simple problem. Let us move to question number 11. Z be a complex number such that mod of z minus I by z plus 2i is 1 and z is 5 by 2, then the value of z plus 3i is how much? Okay, very interesting question. What is the value of this? Okay, let's start. Z is equal to x plus iy, let us assume, and substitute inside. What we have is mod z minus I is equal to mod z plus 2i. So substituting it here, z plus iy minus I under mod is x plus iy plus 2i. So this becomes x plus y minus 1 is x plus y plus 2. I, of course, excuse me, there is an I. Now the mod is square root of x squared plus y minus 1 the whole square. Here it is x squared plus y plus 2 the whole square. Square on both sides and expand this bracket. I get x squared plus y squared plus 4y plus 4. Now x squared, y squared all cancel. And I get minus 6y is 3. Which implies y is minus 1 by 2. Okay. Now also we have y is y is minus 1 by 2. We have mod z is given as 5 by 2. Now mod z is nothing but square root of x square plus y square is 5 by 2. Now this, on simplification, squaring both sides practically, is 5 by 2. Therefore substitute this here, x squared plus 1 by 4 is 25 by 4. Take it to the other side, x square is 24 by 4 or 6. So x is plus or minus root 6. Okay. Now what are they asking us exactly? mod of z plus 3i. So what is mod of z plus 3i? Mod of z plus 3i would become mod of x plus iy plus 3i, and x is plus or minus root 6 plus I into y is minus 1 by 2 plus 3. Now this, you see that this plus or minus has no value now, it becomes 6 under root 6 plus minus 1 by 2 plus 3 is 5 by 2. So this can be written as 5 squared 25 by 4, or square root of 49 by 4, which is 7 by 2. So the answer is 7 by 2, option B. So the answer to question number 11 is option B, 7 by 2. Now you can do this also a bit quickly using some geometry. See, basically what this means is z minus I is equal to mod of z plus 2i, means the distance between the point I and minus 2i is the same, which is the perpendicular bisector. If you remember, such things are perpendicular bisector between these 2 points. That is between I and minus 2i, you need the perpendicular bisector. And that perpendicular bisector is nothing but this plus this by 2, right? That is, it passes through this minus 1 by 2 I. And z is also, mod z is 5 by 2, which is a circle of radius 5 by 2. So z basically is this point and this point, or this point, yeah, where they intersect. So what will be this point? This is minus 1 by 2, which you got now, and then the circle, from the circle you get this point. After you get z plus 3i is, you're just adding 3 to this and then finding the magnitude. Okay, question number 12. Let x, y and z be the respective sum of the first n terms, the next n terms and the next n terms of geometric progression. That is, if you have n terms, first term of a GP is A, AR, so on. Nth term is AR par n minus 1. So these are n terms. The next term would be AR par n, AR par n plus 1. Up to, if I am going for another n terms, I will get AR par 2n minus 1. These are another n terms. And another n terms, see the next n, next n. The next n terms will be AR par 2n, AR par 2n plus 1, up to AR par 3n minus 1. These are another n terms. So they say that x is the sum of the first n terms, y is the sum of the next n terms, and z is the sum of the next n terms. So all these are GPs only, but with different first term, right? In these n terms the common ratios are, in these n terms also the common ratios are, but the first terms are different. So you know that the sum of n terms formula is the first term into r raised to n minus 1 by r minus 1. So x is going to be just this. Y is going to be starting from this first term, n terms. So in the same expression, only the first term will change. So it becomes a r to the power n, r power n minus 1 by r minus 1. The same way, z would become the first term of z is a r power 2n into r power n minus 1 by r minus 1. Now if you see, y is x times r power n, because all this is x, right? I can write y is x times r power n. And if you see here, z is x times r power 2n. So z is x times r to the power 2n. Therefore I have x, y, z as x into r to the power n, x into r to the power 2n. So you can see this is a GP with the first term x, and common ratio is r power n, multiplied by r power n, multiplied by r power n. So the x, y, z I can say are in GP. So option B, geometric progression. Question number 13. The function f of x is equal to fractional part of x into sine of pi greatest integer function of x is what? It is discontinuous at where? Now the first thing to our mind is that box is discontinuous at all integer values of x. This is also discontinuous at all integer values of x. So the answer should be all integer points. But think carefully, this is an integer, which means it is like -1, -2, 0, 1, 2, 3, etc., etc. And sine of any integer into pi is always 0. So this function basically is 0 throughout for all x. So it is just the x-axis. F of x is 0 means the x-axis, which is continuous at all points. There is no discontinuity. You can even say it is differentiable at all points. Therefore, it is discontinuous nowhere. No x is the correct answer. Be careful, don't rush into the answer that box x is discontinuous at all integer points. Question number 14. If there are n number of seats, n seats, and m people, person 1, person 2 up to person m is less than n, so fewer people than seats, then the number of possible ways to make them seated. Okay, so how do you do usually? There are only m people, so first you have to choose any m seats here. How to choose m seats? To choose m seats from n seats and arrange m people in m seats, right? In words, this would be what it means. Mathematically, choose m seats from n seats is NCM. Choose, no? So, selections, combinations. Arrange m people in m seats is m factorial. Now, what is NCM into m factorial? NPM factorial. Sorry, NPM. No factorial here, excuse me. NPM. Okay? So NCM into m factorial is NPM, and the answer is therefore NPMA. Okay. Another way directly to think about this problem as permutation, you can think like this. There are p persons and each one has to be assigned a seat. There are n seats. So how many ways you can arrange? Out of n, you have to arrange n objects to m people where n is greater than m. That is NPM directly, right? So you can come to this answer in one step also. Question number 15, interesting question. Let I be integral 0 to 1 sin x by root x dx and j be integral 0 to 1 cos x by root x dx. Now first of all, remember the integral sin x by root x, cos x by root x and all are not integrable analytically. There is no easy way, direct way to integrate them analytically. And they are, I think, called Fresnel integrals or something. This is also equivalent to the form sin of x squared dx. Such a simple thing, this and this integral and all, cannot be evaluated analytically. You need some very advanced techniques and all that. So, don't even try evaluating them analytically. What has to be done? We are not asked the value of I, but only the boundary for I. I should be greater than something, or j should be less than something, I should be less than something, etc. Okay, how to do such problems? Take j for example. J is integral 0 to 1 cos x by root x dx. Now how is this function going to look? Cos x starts from here, from at 0, cos x is 1, and at pi by 2 it becomes 0. Where does it, at x is equal to 1, it will have some value, no? At x is equal to pi by 4, we know it has value 1. So it is, x is equal to 1 is beyond that pi by 4 limit, so somewhere here. Now this is the region under consideration for this. Now how can we find the upper limit to this integral? Now you see, at all these points in this region, cos x is this curve, cos x is less than 1, no? If I complete this rectangle here, this area is always less than this rectangle's area. That is, this integral will be less than this rectangle's area. Correct? Okay. So, this rectangle, that is, what I am saying is cos x is always less than 1 in this region, less than or equal to. Therefore, j will definitely be less than, instead of cos x, if I write 1 there, it will be less than this integral. Did you get this idea? Because I am putting something here which is greater than cos x. I am putting 1 which is greater than cos x. So the integral will be less anyway. The area will be less. So this can be evaluated now. 1 by root x is x power minus 1 by 2. So if you integrate it, it becomes x power 1 by 2 by 1 by 2 from 0 to 1, which is 2 into 1 minus 0 or 2. Therefore, j is less than 2. This can be established. J is less than 2 can be established. So j is less than 2. So one of these two options. J is always less than 2. Now let us see if we can get a bound for this. How will that function look like? Sin x is going to be like this. At x is pi by 2, it becomes 1. At x is pi by 4, it is going to be 1. Sorry, 1 by root 2 basically, 0.7 something. Now, for this, if you see that you can consider another function to get a bound, that is, you take y is equal to x, the straight line y is equal to x. Let me redraw the whole thing here, a little below. I am not getting the enough space to draw anything. Let us say, what I am trying to say is, you consider that sin x is going like this, right? Increases from 0 and reaches at pi by 2, it reaches a value 1. Now if you consider the equation y is equal to x, at x is equal to pi by 2, it would have reached pi by 2, which is 1.57, no? Pi by 2, so it is greater than this. So y is equal to x, x is always greater than sin x. Understood? X is always going to be greater than this sin x. Therefore, integral sin x by root x dx from 0 to 1 is somewhere here, is always going to be less than integral 0 to 1 x by root x dx. Because x is greater than sin x, it will be less than this. That is, integral I is less than this. I is less than integral 0 to 1 root x dx. Now integrate this. So I is less than, root x is x to the power 3 by 2 by 3 by 2. This becomes 2 by 3. So I is less than 2 by 3. See, without evaluating the integrals, we have using appropriate functions got a proper bound. The bound we are using for sin is x itself. The bound we are using for cos is 1. Therefore, you can say I is less than 2 by 3, j is less than 2, which option? I is less than 2 by 3, j is less than 2, option C. Okay. Simple problem. Guess that these bounds are 1 and x. Okay. Question number 16. Now, for some reason, they have repeated a certain question from very similar question from the previous test. You remember that this, you have to show that this determinant is equal to k lambda into something. Then what is the value of lambda? Okay. Now we'll do I'll repeat the whole solution again. what I am doing is, the first time I am going to replace R3 by R2 minus R3, or let's say R2. Let us replace R2 by R2 minus R3. So here, if you remember, A plus lambda the whole square minus A minus lambda the whole square is going to become A squared plus 2A lambda plus lambda squared minus A squared plus 2A lambda minus lambda squared, or 4A lambda. So the advantage of doing this is I get 4A lambda here, 4B lambda here, and 4C lambda here. And then this also can be expanded and written minus 2A lambda plus lambda squared, B squared minus 2B lambda plus lambda squared, C squared minus 2C lambda plus lambda squared. So let us take 4 lambda common out, and I get A squared, B squared, C squared, A, B, C, and then these 3 terms here. Okay, I have taken only 4 lambda common from row 2. Now you see that this last row, being a summation of 3 elements, can results in the matrix being split into, the determinant being split into 3 determinants. That is, I can write the whole thing as, the first determinant will have A square, B square, C square, A, B, C, and only A squared, B squared, C squared, the first of these terms. The second determinant, I can in fact write 2 lambda common, or if you want it to be a little clearer, let us keep the 2 lambda inside and write A squared, B squared, C squared, A, B, C. I have taken the minus outside, so it is 2A lambda, 2B lambda, 2C lambda, plus A squared, B squared, C squared, A, B, C, lambda squared, and lambda squared. Right? Now this determinant is 0 because 2 rows are equal. This determinant is 0 because these 2 rows are proportional. If I take 2 lambda common, I will get ABC, ABC. So both determinants are 0, only this determinant remains. So if I take lambda square common from here, I would get 4 lambda squared into A squared, 4 lambda cube, A squared, B squared, C squared, A, B, C, and 1, 1, 1. Right? Because I already have 4 lambda and I am taking lambda square, I get 4 lambda square. So comparing with this, K lambda is this 4 lambda cube, or lambda into K minus 4 lambda square is 0. Either lambda is 0 or K is 4 lambda square. But they have given us lambda is not equal to 0. So this, no, only this. So K is 4 lambda squared, which is option C. Okay? Okay. Let us move on to question number 17. Question number 17 is a very simple question based on statistics. The coefficient of variations of 2 distributions are 60% and 75%. I hope you remember what is coefficient of variation, right? Coefficient of variation is defined as the standard deviation by the mean times 100 in percentage. If you need it in percentage, it is like this. Now, they have given that the first one is how much? CV1 first is 60%, is the standard deviation is 18 and 15. So the first one standard deviation is 18 by x bar 1 into 100, or I can say that x bar is going to be 18 into 100 by 60, or 3 times, which is 30. So the first one is 30. What about the second one? 75% is 15 by x2 bar. The standard deviation is 15 and 100. So x2 bar is 15 into 100 by 75. One's 5 times, and this cancels to give 20. So x2 bar is 20, x1 bar is 30, and x2 bar is 20. So 30 and 20, option B. Moving on to question number 18. The solution of this, x belongs to R. For this, what are the elements R basically? How to solve this? Very simple problem. 2 cos squared x is nothing but cos 2x plus 1, right? Because you know cos squared x is 1 plus cos 2x by 2. So if you want it explicitly, let me write it. Cos squared x I am writing as 1 plus cos 2x by 2. Or this becomes, this 2 and 2 gone. Cos 2x plus cos 2x is 2 cos 2x is 1 gone there, 1. So cos 2x is 1 by 2. Okay. This is nothing but cos pi by 3. Therefore, 2x should be equal to 2 and pi, we know the direct solution, plus or minus pi by 3. Or x should be n pi plus or minus pi by 6. Okay, so it is n pi plus or minus pi by 6, which is option B. So the answer is option B. Question number 19. A limit x tends to 0, log of 1 plus x by x squared plus x minus 1 by x is how much? Okay. Now this is very simple if we know the series for log 1 plus x. It is easy even if you don't know. You know that 1 by 1 plus x is 1 minus x plus x squared minus x cubed and so on. If you integrate both sides, you get log of 1 plus x is, how do I get this? This is a geometric progression with a1 and r minus x. So you know the sum to infinity is a by 1 minus r. So a by 1 minus minus x is a by 1 plus x. If I integrate both sides, I get x minus x squared by 2 plus x cubed by 3 minus x power 4 by 4 and so on. Substitute this there and see what happens. So limit x tends to 0, x minus x squared by 2 plus x cubed by 3 minus x power 4 by 4 by x squared plus x minus 1 by x. Let us split these terms. Each term divided by x squared is 1 by x minus 1 by 2 plus x by 3 minus x squared by 4 and so on. And here I have plus 1 minus 1 by x. Right? X by x is 1 minus 1 by x. Cancel minus 1 by x and I have, of course the limit is still here, limit x tends to 0. If I substitute x tends to 0, all these terms vanish and I will only have minus 1 by 2 plus 1, which is 1 by 2. So the answer is B, 1 by 2. Okay, very straightforward problem if you know the series. Lots of series can be obtained like this quite easily. Okay, moving on to question number 20. The abscissae of the points where the tangent to the curve y is x cubed minus 3x squared minus 9x plus 5. Now abscissae means the x coordinates, right? Now tangent is parallel to the curve, that is basically there is a curve like this. Tangent is parallel at the minima and maxima, right? Slope of the tangent is f dash of x. If it is parallel to x axis, then f dash of x is 0, which is the same condition as the maxima and minima. So differentiate this, put it equal to 0. dy by dx is equal to 0 implies 3x squared minus 6x minus 9 is 0, or x squared minus 2x minus 3 is 0, or x minus 3 into x plus 1 is 0. So I get x is 3 or minus 1. So 3 and minus 1, option D. Very simple, differentiate and equate it to 0. Question number 21. Now whenever there is a modulus and all, even I get a bit nervous. Let us see how the question proceeds. The value of x for which x is a real number for which you have this equation satisfied is what? Let us do it a little carefully. X minus 1 into x squared minus 4x plus 3, and this can be factorized, right? I can write 2x into x, and I should get, to get 3, I need plus 5 and minus 1. Okay, you do the factorization and you'll see x minus 1 into mod of x squared minus 4x plus 3 plus 2x plus 5 is 0. Now this gives x is equal to 1, or this whole term is 0. So we'll take this whole term 0 and x is equal to 1 is one solution. If I take the whole term 0, this has two cases. If the mod term is positive, then you can just drop the mod, right? Then the equation becomes, so this is case 1, x squared minus 4x plus 3 plus 2x minus 5 is 0. And this would become x squared minus 2x minus 2 is 0. And what will be the roots? X belongs to R, remember? Sorry, 2x plus 5 here, 2x plus 5, my carelessness, 2x plus 5, so this is plus 8. What will be the roots? X is equal to minus b plus or minus square root of b square minus 4 square is 4 minus 4 into 8 by 2. Now this is going to be imaginary, so this case is not valid. Let us take x squared minus 4x plus 3 is less than 0. Then the equation would become minus of x squared, this mod becomes minus of this term, right? So minus of this plus 2x plus 5 is 0. Okay, so this is, if I were to simplify, minus x squared plus 4x plus 2 is plus 6x, right? What do I mean? Minus 4, minus of minus is plus, and plus 2, plus 2x. Then minus of 3 plus 5. So this gives me x squared minus 6x plus 2 is 0. Okay. So there is this equation. Now let's find what are the roots of this. So x is what happens here? X becomes 6 plus or minus square root of 6 square 36 minus 4ac, 4 into 8, right? 6 squared minus 4 into 8 by 2, or this becomes 6 plus or minus square root of 28 by 2, or x is 6 plus 2 root 7 by 2, 3 plus or minus root 7. Now, are these values allowed? Are these values allowed? How to determine that? See, first of all, at least when it was positive, this was imaginary, and so it is not allowed at all. But here, we have a certain condition already, right? We have said mod of x square minus 4x plus 3 is less than 0. That is this, I'm sorry. That is without the mod here. Mod is always greater than 0. Remember, these two conditions are without the mod. If this is less than 0, then the mod becomes positive in this case. Mod will be positive in this case. If it is less than 0, mod will be negative in this case. That is what we have done. The idea was correct, I just put the mod accidentally. So we have taken that x squared minus 4x plus 3 should be less than 0, right? If this is the case, this is under the condition if x squared minus 4x plus 3 less than 0, or x minus 1 into x minus 3 is less than 0, which means x should be between 1 and 3, this domain. The first condition was x should be outside this domain. So now x is in this domain. If you see 3 plus root 7 is beyond this domain, right? 3 plus root 7 will be somewhere here. What about 3 minus root 7? 3 minus root 7 is 3 minus 2 point something. So it will be point something, right? So it is less than 1. So 3 minus root 7 is here, 3 plus root 7 is here. So it is not within the actual region where we have considered the root. So even this is not allowed. So the only allowed value is x is equal to 1. So the answer is x is 1. This is the only allowed value. Question number 22. f of x is 9x by 25 plus c. If the curve y is f inverse of x passes through 1 by 4 minus 5 by 4 and g of x is the antiderivative of f inverse of x such that g of 0 is 5 by 2, then g of 1, the box function of g of 1. A lot of things, but everything is a very simple term here. See, they have given us f of x is equal to 9x plus 25 plus c. Let us try to find f inverse of x. That is, let us say some u is 9x by 25 plus c. Find x in terms of u, that will be the inverse, right? So u minus c is 9x by 25, or x I can say is 25 by 9 u minus c. So if I have to write it as a function of x, I can say y is equal to 25 by 9 x minus c is that f inverse of x. Okay, so first thing is f inverse of x. Now what do I have? They have said f inverse of x passes through 1 by 4 comma minus 5 by 4. So 1 by 4 comma minus 5 by 4 satisfies this. Substitute that and I get minus 5 by 4 is 25 by 9 into 1 by 4 minus c. All this is to calculate what is the value of c. So let's see. Take it to the other side. Minus 5 by 4 into 9 upon 25 is 1 by 4 minus c. This is 9 by 20. Transpose it to the side. C is 1 by 4 plus 9 by 20. So 20 is 5. Let us say what I mean is minus 5 by, it passes through minus 5 by 4, yeah. So 9 by 5, 9 by 20, okay, 9 by 20 is equal to 1 by 4 minus c. This becomes, if the LCM is 20, 5 times, so 5 plus 9 by 20, which is 14 by 20, or 7 by 10, in other words, let us say 7 by 10. So C I have got as 7 by 10. So the f inverse of x is 25 by 9 x minus 7 by 10. Okay, so far so good. Nothing involved or no complication at all. All that we are doing is just balancing the terms. Like, okay, like next thing is to find g of x is the antiderivative of f inverse of x. That is, g of x is the antiderivative, means the integral of f inverse of x. So that is the integral of 25 by 9 into x minus 7 by 10. Okay. Now this is easy to evaluate. If I multiply it inside, I get 25x by 9 minus 175 by 90 dx integral, of course. So this becomes 25x squared by 18 minus 175x by 90 plus some constant. Now they have given us g of 0 is 5 by 2. So basically, if I put g of 0 is 5 by 2 here, 5 by 2 is equal to c will be what I get. So g of x is finally 25x squared by 18 minus 175x by 90 plus 5 by 2. What have they asked us? They are asking us what is box of g of 1. G of 1, first of all, is going to be 25 by 18 minus 175 by 90 plus 5 by 2. This becomes, if I take the LCM, 5 times, so 125 minus 175, and then here to make it I need to multiply by 45 and 45, so it becomes 225. So 225 plus 125 is 350 minus 175 by 90. Now the box of this is box of 175 by 90. How much is 175 by 90? It is some 1 point, possibly 1.9 something. So this is actually 1. So the answer to this problem is 1. Okay, very simple problem. First find the inverse function, substitute this point, get the constant c, and once you get the constant, get the antiderivative, because that is g of x, that is integrate this basically. After you integrate this, you get the value of that constant of integration, and then find the box of g of 1. That is box of g of 1. Okay. Question number 23. Let x plus 1 by x is 2 and y plus 1 by y is minus 2, and sine inverse of x plus cos inverse of y is m pi. Then the value of m is. Now, if x plus 1 by x is 2, you would have guessed that x has to be 1. That is the only thing that satisfies the solution. But to get it explicitly, you multiply x squared, take the LCM basically, and you get x squared minus 2x plus 1 is 0, or x minus 1 the whole squared is 0. So the root is only 1. The same way, y plus 1 by y is minus 2 would result in y squared plus 2y plus 1 is 0, or y plus 1 the whole squared is 0, y is minus 1. Okay, so what we have is sine inverse of x plus cos inverse of y. We found that x is 1 and y is minus 1. So 1 is, sine inverse of 1 is pi by 2. Cos inverse of minus 1 is pi. So it's like 3 pi by 2. So they have said that this value is equal to m pi. So what is the value of m? M is 3 by 2. Or 1.5. So the answer is 1.5. Okay, very simple problem. 24. I cross a minus j cross I plus j cross a minus k cross j plus k cross a minus I cross k is 0, and a is xi plus yj plus zk. Then the value of this whole thing is what? Okay, this is very simple. All you have to do is substitute this here and see how these three terms are, add them, equate them to 0, and then see what you get. Okay, so how can we do this? Is there any other alternate way of doing the whole question is what I am asking. That is, see, you know that A cross B cross C is A dot C minus, A dot C into B minus A dot B into C. Always remember, multiply the farther term and then this. First is this, and then the second is this into the other vector. Okay, something like this is possible, right? So I have I cross A minus J cross I. So this can be written as I dot I times A minus J. Then I can write minus I dot this A minus J times dot I into I, right? So how much does this become? This becomes I dot I is 1 and A minus J alone remains. So A minus J, and what happens here? Here what I have is A minus J dot I into I. Now A minus J dot I is nothing but A dot I minus J dot I into I. So this becomes A minus J minus A dot I is okay, But if you know j dot I is 0, right? So it just becomes like this, a dot I into I. Okay? Okay. So this is the first term. This term is a minus j minus a dot I into I. The same way you can show that the second term, let us call this 1, this has 2 and this has 3. So this is 1. Now the second term you can show is with j, right? See here what has happened. This term has come just like that, and with I it has become a dot I into I. So this term also will become a minus k, just that, and then minus a dot j into j. And the third can be written as a minus I, whatever is inside, minus a dot k into k. Okay. Now what will happen to all of this if you add 1 plus 2 plus 3? 3a minus I minus j minus k minus of a dot I into I minus of a dot j into j minus of a dot k into k. Or if I take this minus common, I can put plus to everything. Do you know what is this? A dot I into I plus a dot j into j plus a dot k into k. A dot I, for example, a dot I will be only x. So this will become xi plus yj plus zk. A dot j will be y, a dot k will be z. So this is nothing but a again. So the whole thing is 3a minus I minus j minus k minus a vector, or 2a vector minus I minus j minus k. So now let us substitute this. This is nothing but 2xi plus 2yj plus 2zk minus I minus j minus k. This becomes 2x minus 1i plus 2y minus 1j plus 2z minus 1k. This is given to be equal to 0. Therefore, 2x minus 1 is 0, x is 1 by 2. The same way y is 1 by 2, and you will get z is also 1 by 2. And what have they asked us to calculate? 8x cube minus xy plus zx. Now everything is 1 by 2, 1 by 2, 1 by 2. So this is 1 by 8 minus 1 by 4 plus 1 by 4, which turns out to be a nice 1. Okay. So the answer is 1. Very simple problem. See, if you find all this part difficult, you can go ahead with this with the direct way. What do I mean by the direct way? I'll show you one example. See here, what we have is I cross a minus j cross I, right? Do it directly. I cross a minus j is xi plus y minus 1j plus zk. The whole thing crossed with I. Now what this will become? I cross I is 0. So I'll have only y minus 1. J cross I is minus k. K cross I is j. Then I cross these two terms. I cross k is minus j, right? So it will become plus y minus 1j, and I cross j is k, so z into k. So this is the first term. The second term, cycling it, you can write, you write cycle I by j, j by k, k by I. So j becomes k, y becomes z, and this can become x. This is I. The third term, cycling again, you get x minus 1 I, all vectors, plus x y j. Right? Now if you add all these three, 1 plus 2 plus 3, you will still get see here, there is a y minus 1j and yj, x minus 1i and xi. So you get 2x minus 1i plus 2y minus 1j plus 2z minus 1k. So this again gives x is 1 by 2, y is 1 by 2, z is also 1 by 2. So do it directly if you find that difficult. But be careful with I cross k, j cross I, k cross j, all that. And learn to rewrite this cyclically. That is, you can replace x by y, y by z and z by x. Same way, I by j, j by k and k by I. Using that you can get this quickly. The last problem, a circle touches the hypotenuse of a right angle triangle at its midpoint and it passes through the midpoint of the shorter side. If 3 units and 4 units are the lengths of the sides other than hypotenuse and r be the radius of the circle, then the value of r is. Interesting question, huh? Okay, but it's not very difficult. Let us take the right angle triangle to have its vertex at the origin. Okay, something like this. This is origin. They said the two sides are 3 and 4. So this should be 0, 3 and this should be 4, 0. Shorter side, okay? And a circle is there which touches the hypotenuse of the right angle triangle at its midpoint. So here right at the midpoint, this point would be 4 by 2, 3 by 2 or 2, 3 by 2. Right? Midpoint of these two is 2, 3 by 2. At this point, there is a circle which touches this. Okay? So imagine there is a circle, and what have they said also? The circle passes through the midpoint of the shorter side. The midpoint of the shorter side is going to be 0, 3 by 2. The circle also passes through this. It is tangent to this and passes through this. Okay? So you get a circle like this. Okay. Now we have to find the radius of the circle. So we know that it passes through these two things and the tangent, there is a certain tangent also. What will be the radius? What will be the radius? Yeah, basically what will be the radius? How to go about this problem? Let us say this is the center of the circle and now this line we know is the radius and this also is the radius, right? Both are equidistant, that is the point 0, 3 by 2 and 2, 3 by 2 are equidistant from C, right? Let us call this center as H, K. I can say, let this point be P, let this point be Q. I can say CP should be equal to CQ, equal to the radius basically. So this will give me one equation definitely, right? What will be that one equation? Let us write Cp is going to be square root of Cp. So H minus 2 the whole square plus I get here K minus 3 by 2 the whole square is CQ is going to be H minus 0 the whole square plus K minus 3 by 2 the whole square. So this on squaring both sides and then you can cancel these two terms and expanding. This is H squared plus 4 minus 4H is equal to H squared. I am cancelling these two terms, square and then cancel. You can't cancel right now. So if I were to cancel both these points where let us say H squared and H squared here. Okay. What do I get? 4 minus 4H is 0 or H is equal to 1. So already I found one coordinate. It's left only to find the other coordinate. How can you find the other coordinate? Many ways. One way is to say that this line is perpendicular to this tangent, right? Now this tangent, the equation of the tangent, I am using the idea Cp is perpendicular to tangent, okay? So the equation of the tangent is going to be x by 4 plus y by 3 is 1. Therefore, the slope of the tangent is minus of 1 by 4 by 1 by 3 or minus 3 by 4. So, slope of CP should be plus 4 by 3, perpendicular. Okay. So, I get this equation of the tangent, slope of the tangent and the slope of CP. Once I get slope of CP, write the slope of CP using the normal point form. CP is like this. We have found this is 1 comma k, and here I have 2 comma 3 by 2, and the slope is already known to be 4 by 3. So 4 by 3 is y2 minus y1 by x2 minus x1. Okay. So this will give me minus 4 by 3 because this is minus 1. Right, this value is minus 1. Take it to that side. Minus 4 by 3 is k minus 3 by 2, or k is 3 by 2 minus 4 by 3. On LCM, this is 9 minus 8, 1 by 6. So h comma k is 1 comma 1 by 6. Okay. Do the calculations properly and everything is simple. Now what will be the radius? Radius r is CP basically. So find the distance between these two. CP is square root of 2 minus 1 the whole square plus 3 by 2 minus 1 by 6 the whole square. So this is square root of 1 plus the LCM is 6, and this becomes 9 minus 1. Right? 6. So 9 minus 1 by 6 is 8 by 6. And the whole square, which is square root of 1 plus 64 by 36, or square root of 100 upon 36, 10 upon 6, 5 by 3 let us say. So the radius is 5 by 3, they are asking us 3r, be careful there. 3r therefore is 5 by 3 into 3, which is 5 units. Okay, so that gives me the answer to this problem as 5. A very simple problem indeed. Remember the ideas we have used. One is the center is equidistant from the 2 points, and the next is the radius is perpendicular to the tangent. This brings us to the conclusion of NTA test paper 10. I'll see you again with NTA test paper number 11. This is SANTOSHSIR from Parth Tank Mathematics Institute, Ahmedabad.